Hey guys, what's up? Eddie Aho here with KissAnalog.com. Hey, so today what I want to do is I have a Class A amplifier here. It's one I found in a bunch of videos. I call it the 20 watt Class A. It's actually closer to 25 watts and 8 ohms and about double that in 4 ohms. So I did a bunch of videos, did a bunch of testing, and today okay, let me go back a little bit. I got this back because there's a few things I had to finish up on it, and one of these knobs, the pot, the little thing right here, got broken. So I put a new one in, but I ended up putting two new ones in to match. So I did a little rework on it, and then I did some bunch of testing to make sure everything's good. And so in the meanwhile, I thought before I give it back to my buddy who is dying to get this thing back, I thought I would do another test, just kind of show you the difference between the Omicron, the Bode 100, and also the Quant Asylum box. They're sitting underneath my computer here. I'll show you this setup here in just a moment, okay? But what I want to do is show you some Bodes, the Bode plots. But instead of normally where testing is done at 1 kilohertz and 1 watt, for THD, that kind of thing, and then Bode plots are usually done at the 1 watt thing as well, I want to do 1 watt and then also do closer to 25 watts, okay? So, and then maybe something in between. And I want to do it on the QuantAsylum to kind of show you the setup and all that, and then also then do it on the Omicron, okay? The Omicron costs a lot more. We'll talk about all that stuff later. Let's just jump in and do this video. But just to explain how I'm going to set this up, I'm going to show you the setup. It might give you an idea, a better idea of what's going on. And essentially what I'm going to do is I'm going to manually set the level at, say, 1 kilohertz. I'll choose 1 kilohertz. The one nice thing about 1 kilohertz is you see all the harmonics out to 20 kilohertz, and if you go, to 5 kilohertz, you only get a couple of harmonics. So 1 kilohertz is a good, frequency for that. 100 hertz would be good, I guess. But, if the filters are rolling off at the low frequency and a high frequency or whatever, 1 kilohertz for that reason also seems to be a good spot because you get maximum amplitude. But so that's part of the thing. When I do the Bode plot at max amplitude, max power out, I also want to make sure that at the low frequency and the high frequency that it's not clipping. So I want to check the clipping at low and high frequency as well as 1 kilohertz. And sometimes in engineering we call it the corner cases, where you test like the extreme limits and then all the stuff in between is probably good. So if you test, like, let's say 20 hertz at max amplitude, 20 kilohertz max amplitude, that's 2 corner cases, and then you can go, well, also let's go down to 1 watt or even something less than 1 watt, and you go down, say, some low frequency and high frequency. That'd be like 4 corner cases. So I might not be going to the extreme corners in this situation, but we're going to do the 1 watts down on these bottom corners at 20. We're going to scroll the bandwidth, but at first I'm just going to check to make sure I'm not going to start getting flat tops, where you get all that distortion. Once you start deconstructing sine wave, flat topping it, you're deconstructing it into a square wave, and it takes a whole bunch of different sine waves and different amplitudes to build a square wave, essentially. So when you cause a square wave, it's like you deconstruct it, you shatter it, and you get all these harmonics poking up all over the place. And just to let you guys, well, anyway, let's just jump over here and take a look at it. Now I'm going to use this scope to look at the actual flat top to see the shape of the waveform, but also looking at the THD waveform on the QuantAsylum, you'll be able to see, all of a sudden it starts deconstructing. You start seeing all of a sudden all these harmonics popping up when you start to flat top. So you can actually see it in an FFT or, when you're looking at the frequency domain. So just to remind some of you guys, frequency domain versus time domain. If you've seen an oscilloscope where time domain, you see a sine wave, you know, as the voltage and it goes along the frequency. Time, it's going up and down, but it looks like, you know, a sine wave. And if you look at that in frequency domain instead of the time domain, and if it's 1 kilohertz, you'll see a spike right at 1K. And let's say this is 1K and 10K's here, you'll see a spike here and a spike here if you have two frequencies, a 1K and a 10K. If you have 1K, 2K, and a 3K, you'll see spikes at all those things. And those are harmonics, multiplications of your fundamental frequency, okay? Those are all your harmonics. So that's THD, total harmonic distortion, because you add up all those harmonics, and that's your total harmonic distortion. And then there's also total harmonic distortion plus N. Now, I've done a bunch of those kind of measurements on this across frequency, across amplitude, but today I just want to do the Bode diagrams. But you will see some of that spectrum stuff when I'm trying to set it up before we do the Bode. All right, so let's just jump over here and do it after all this talk. Okay, let's do it. All right, guys, so here's the setup, okay? Just want to show you my MacBook there. There's what the screen's looking like right now. Here's the beauty guy right down here, the Quant Asylum. That's how he's hooked up, okay? 24-bit ADC, 192 KESPS. And then here's one of the 8 ohm loads. He's tied in right back here. I've got my differential probe so I can watch the screen, make sure I'm not flat topping. Even though I you know, you can tell in the window, but I just like to look at the waveform as well. That's the other 8 ohm load for the other channel. And then here's my KPS setup here. So I'm looking at, see, there's 0.74. Right now I've got, oh, that's line 1. This is a nice meter. Yeah, so right there, 0.7. It's kind of bouncing all over because of the 114 watts, because of the way it's pulsing like that. See how it's pulsing? So, and this guy up here, he's showing a little bit higher wattage. So I believe the KPS. So there you go, guys. Pretty fun, huh? You know what? I'm going to show you the screen, kind of walk you through the screen, what it looks like, okay? So over here on the right side is all the setup kind of things. Yeah, let me pull that down. Whoops, there we go. QuantAsylum audio analyzer, okay? We're going to do frequency, not time domain. So right now we're going to do frequency. We're going to look at the spectrum, and we're going to look at the input and left channel, okay? And we're going to look at dB volts. So that's this axis here on the left. It's 30 dB at top, minus 160 at the bottom. I mean, these analyzers, they both have 24-bit A to D chips in them, so they have lots of resolution. They can really show a low noise ground floor. We're going to look at X log. So across here, it's logarithmic. 10 hertz, 100, 1K, 10K, 100K. Now, from 10 to 100, that's 100 hertz. In the same distance in the next grid, you see 100 to 1K, so that's 10 times as many frequencies in here. Then 1K to 10K, same thing, 10 times. So that's logarithmic, where things are compressed. You know, guys, it's like if you're downtown, like I like to say, if you're, like, say, in New York City, big city, and if you're trying to take a picture of the little people on the street and the tops of the buildings, I mean, it's really hard to get a wide angle lens, and if you do, the people are teeny. They're really hard to see, you know, any definition in them, and the buildings are so big, they're kind of hard to see too. So if you compress the buildings down and make the people bigger, you know, you kind of compress things, then you can see definition of both. Now, somebody would have to tell you, okay, this, you know, every grid when in your picture is a 10x thing. And so you go, oh, okay, so then this is 10 grids, this is really stretched out this big. So that's kind of logarithmic stuff, okay? So over here, vertically, we have log, and across the screen we have log. So it's log. So now look at, here's 100 hertz, here's 200 hertz. 200 hertz is you know, if you look the distance between in the major grid from 100 to 1K, 200 is God, a third of the way, quarter of the way through, and then 300's closer, 400's even closer, and then they get compressed, right? So between 9 and 10, they're right next to each other. That's what I mean by compressed. So both vertically and horizontally, they compress so you can see things better. So that's the advantage of log. It just takes a little math to figure out what the actual amplitudes and stuff like that are in volts. But okay, so at the top of the screen, that'll help you out. Up here where I'm showing you is peak 23 volts dB. That's this picture right here that I captured. It's kind of frozen. And then that is equal to 14.22 volts RMS. And the total harmonic distortion is about almost minus 44, or 0.66 basically. And THD plus N is 43.6, you know, almost the same. So you can look at all these numbers in here. Like here's generator. This thing was at 1 kilohertz and right at 0 dB. So that was equivalent to about 25 watts. Okay, I'm going to go ahead and run this. And we're going to do a hamming, you know, just the filtering, the window filtering. And we're going to look at, you know, these boxes I have checked are all these things up here. Signal to noise ratio is up here too. And then if I hold the button down on this, you see 1 kilohertz, 0. So I'm going to go ahead and just turn that on so you can see that generator, that screen we just saw. There we go. Now this is running, and over here on the scope I'm looking at the sine wave, and it kind of goes on and off because it kind of sets out these bursts, and that's how it analyzes it. So sometimes you'll see the screen just change because it resets and starts over. So right here we see this is, yep, there's a reset that I was talking about. So right here, 1 kilohertz, we're seeing 23 dB V's right up here at the top. And this is 2 kilohertz, so this is the first harmonic. Well, this is the first harmonic, the fundamental. This is second harmonic, third harmonic, fourth, and so on, okay? So these are all multiplications of this guy. Now over here, we see 60 hertz. See, there's 100, 90, 80, 70, 60. So that's this peak. That's the power supply. And then there's 100, and that's 120. This is 200 over here, so 120, and then 180. So we get another harmonic, and these are all from the power supply. So every 60, you know, you just add 60 and you get the next one. So 180, then, whoops, we reset, and then 240 and 300. See, it landed right on 300. So those are power supply noise, the low frequency switcher, the diodes turning on and off. All right, so now let's go ahead and turn this off, and let's go up here and run a plot, and we're going to see what we get. So I can just run this single guy, okay? I can go output level 0 dB, and I'll just run it. Here is what it's doing. So it looks like it's kind of down here, then it kind of comes up, and then it drops down again. So that's the Bode plot, okay? But you know what? Let's run a few Bode plots at different amplitudes, okay? All right, guys, you know what we want to do? What we want to do is find the 1 watt level to see what 1 watt is. So what we want to do is come over here, turn on this generator, and I'm going to turn this on at 1K, just so we know what the numbers are at 1K, and I'm going to start off at 0. That's full power. And I'm going to turn that generator on. Oh, but you know what? Before I do that, I want to turn on all these boxes that got turned off. Okay, signal to noise. So you can watch the screen up here whenever you want to see what level we're at. Like right now, 14.27. That's probably close to 25 watts, and it's 23 dB, and we have a gain of about 23 right there. But here, let me just go ahead and run this. And it's going to show you all that information. And now I'm going to drop it down to where it's about 2.7, I think, 1 watt. So let's drop it down and see where we get to. Let's see where that is. That's still going to be a little bit high. I mean, I could do the math and calculate it, and I could show you how to do that. But for now, I just want to kind of show you, you know, this tool and how to use it without even doing any math. So we're 2.8. Well, now we're, okay, hold on a second. It's got to settle in. It does some averaging and stuff. Okay, so that's pretty close to 1 watt. A little bit lower, probably. Pretty close, though. Maybe if I go 1 grid up. 1 notch. All right, that's pretty darn close to 1 watt right there. So let's go look at the generator to see where we're set, because I kind of lost track. Okay, minus 14 right here. And actually up on the screen, it says generator 1K, well, 999.7 hertz and minus 14 dB. So I didn't even have to open the window. I just have to look up here. So minus 14 and 0 is max power. So let's go ahead and run our automatic tests, and we'll run a whole bunch of, we'll run several plots at least. Did I say minus 14? Let's do that. Minus 14. Okay. I went dot 0. Okay, minus 14 to 0. And we're going to do that in 7 dB increments, I guess. So we're only going to get a few plots, but that's all right. You know, I canceled that. The other thing is, see the FFT is 256. I really don't need that many points because these are pretty much straight lines, so that they really don't need a whole lot. So I think 64, it'll make it run a lot faster if I do it this way. So let's go back here and I'll say rerun that last test. So yep, that's what I want to do. And we're going out to 30 kilohertz because we just want to see it roll off around 20. I know it rolls off around 20, so let's just go ahead and do that. I'll say go, because it takes a while. So I'm going to move this window down here. And it starts off pretty fast. Now look, over here, this is 60 hertz, right? Here's 100 down here at the bottom. And if you go 90, 80, 70, 60, so that's the 60 hertz line frequency. And this one is 100 hertz, so right next to it's 120. So that's the, after the bridge rectifier, you get double the frequency. And then over here is going to be 60 hertz on top of that, so it's going to be 180. And then the next one is another 60 hertz, so it's going to be 240. And then the next one, 60 hertz more, 300. So yeah, you can see this is all from the power supply, the 60 hertz power supply. If you're in Europe, that'd be 50, that point would be here, and this one would be right on the 100, and so on. And then over here on the right, you can see the harmonics. Here's the fundamental, here's that harmonic for this is just a multiplication. This is 2 times whatever frequency that's at. And then you see these other harmonics. So at first these guys are kind of hidden in this tall grass, but as they come down here where the noise for, I call this the noise for, this real thick area, and you see those little spikes. Now, see, it's going a little faster because I did 64K, and you can see we're at 6 volts RMS, so we're above the 1 watt thing now. And I went to 30, so you see this frequency right here. This is our fundamental frequency. As soon as it gets to 30K, it'll start over and do another sweep. Okay, there's the next sweep, and it races through. So yeah, these are all the harmonics, and some of them actually grow as it travels across, right? So that's kind of interesting. I mean, we could do, in the previous videos where I did the harmonics, or the THD versus amplitude and versus frequency, I did that at the 4 ohms, so I could redo that at 8 ohms. Let me know if you guys want to see that. But today we're going to just do the Bode plot. So we're looking at the time domain as it's sweeping, but you'll see all the Bode plots pop up in a little bit. Alright, so I'm going to speed through this and we'll kind of race through this. Alright, guys, that was pretty cool. There's the graph right there. So here, let me blow that up. Now, this is kind of curious. It starts, it starts around 21, 22 dB, and then it kind of ramps up to 23, so it goes up about a dB and a half, and then it flatlines, and then it drops off. I feel like there's a internal dB offset because I thought it would be down around 19 dBs instead of 21. So that kind of surprises me a little bit. But yeah, so anyway, if you look at this, they're all on top of each other until you get 10K, and then they kind of spread out. And the red one, if we come over here, that's the highest dB. Now, you know one thing about blowing it up like I just did? I hate doing that way because I don't like the way the QuantAsylum thing handles that. I like this bar, like the decibels to be on the left side and the phase to be on the right side. And so I have to keep the window kind of long and rectangular, because if I make it too big vertically, it does that thing like that, which I don't like. Oh yeah, yeah. And then I don't like Windows automatically sizing things for me either. That's, jeez. You know, Windows thinks it's trying to help you, but sometimes it should just stop trying. Oh my heck. Okay, so I just gotta be careful not to let Windows take over. And anyway, so now I get, you know, more room in here to look at this graph. But yeah, so at 10K they're all together, and then they start to separate. The red one is this higher power curve, and then the other two are very close together over here. And 20K is this line right here, and it crosses 20K. These other two cross 20K just below 21 dB. So I mean, you know, we're blowing this up, and so it looks worse than what it actually is, I think, because we're only, if you said the average was somewhere in here, we're, you know, we're minus down to this and plus up to that, it's plus minus half or half a dB or something like that, or, you know, it's not that much, right? And then over here, the red one's a little bit more, because I'm not sure what just happened there. But the red one at 20K is down here below 20 dB. So yeah, the red one, high power, drops a little bit more. And the phases, for some reason, didn't show the phase out here, but I think it's going to probably come up like this and down. It's usually what they do. And then they kind of drop down like this. But it's only showing us this part for some reason. I'm going to drop this window. I want to go look at this generator here, this setup, because I'm just curious why. Let me hold this one down. Hold this one down. I have to look at these windows to see where the settings are. Load impedance 8 ohms, that's correct. I just wonder if there's some offset. There's a weighting thing, which that's off, so that can't be doing anything. But, yeah, I'm not sure why the gain seemed to be off. You know, I'm going to try something, guys. I'm kind of wondering, my input is not differential, but my output is. I wonder if that might be changing the gain, because it is a different amplitude when you go differential versus single-ended, okay? So that could be the thing, because that gain seemed a little bit too high for me. Give me a moment. I'm going to put another lead down on the input, and we're going to go differential on that and see if that changes it. Okay, so guys, what I did is on the QuantAsylum, on the output, the signal generator, I did a differential. So I got two pluses, you know, two reds, right? And I've got the plus one on the plus port going to the plus, and the plus red on the negative one going to the ground, and then I have the two grounds tied together, so it's differential, okay? So now I've got differential input and differential output. Let's see if the gain's changed. So what I want to do is come down here. So I've got the generator, I'll show you. We're going to change that to 1K again. Whoops, you know what? I want to check the amplitude. Okay, I want to change that to 0 and see if that is still our, or I just want to see how that's changed, if it has. Yep, it's totally square wave now, so I gotta drop the signals down. Okay. Yeah, that really, yeah, so that's changing. So I have a feeling that's why I thought the gain was so high. All right, so now that I have that at 0 dBs, now I'll turn the amplifier up to where I get just below clipping and find out, that way I have my volume control knobs here set. So, okay, I'm just starting to clip. That's 14.9, so I'm going to drop down to about 14.5. And then I'll do both channels the same way. And I'll watch the VU meters because they track each other pretty well, I think. I think if I had scope probes on channel 2, it'd be looking pretty darn close to channel 1. And when I look at the power from my meter here, it's 130 something watts, which I think that's, here, let me turn on the KPS meter and it'll tell me power readings. If I get in the right setting, yeah, 135 watts. So that 135 watts to get 25 and 25 watts out. So not efficient. It's a Class A. That's why I can wear short sleeves in my lab when it's only, what is it, 16C in here. This is my CO2 thing to tell me everything's safe. So, but it tells me 16C, which is pretty chilly. I got short sleeves on because I'm working with a Class A. If that tells you anything. 130 watts. I think it's like 90 watts or something like that, just standing still without any signal. Okay, so that's the max signal. And now I think we should, here, I'll find out what the amplitude is. It should be the same, I think, for 1 watt. That's about 2.7, 2.8 volts. Okay, that's about 2.8 right there. And let's see where the generator's set. Yeah, minus 14. Okay, so let's go ahead and rerun those. Okay. I'm going to turn this off. And, hey, by the way, if you look at that curve, wow, I just noticed something. Here, first of all, I got to turn on all these things. RMS, THD. You know what? Oh, that's interesting too. All of a sudden the THD looks way better. So, yeah, I mean, the power supply noise spikes are still there, right? You still see them. But look at all this noise. And the THD, you can see the numbers are minus 60 now. So, and also the harmonics, I don't see as many harmonics. So, man, putting a differential output from the signal generator helps a lot too. It's good getting off the ground. The ground's a noisy place. So, people think ground's quiet, like 0 volts. It's not. It's where you filter all your junk into, right? Ground's just a messy domain. It's kind of like your sewage. Yeah, it's nice and flat, but it's full of crap. So, anyway, ground's not what people think it is. Anyways, so, boy, I'm kind of excited to run this test out. Let's get into it and do it. Let me stop talking. Okay, I'm going to go ahead and run it. And this time, since you guys know what to look for, yeah, that does look better, huh? You can see the 2 harmonics, the second and third harmonic, running along with it. But I feel like they're lower. They're not as dropping off as much. I mean, not increasing. You don't see other harmonics jumping up with it. You still see the power supply noise over here on the left. All that stuff there that doesn't change with the amplitude, the signal running across the screen, that's just ambient noise from the power supply and other stuff. But yeah, a lot of that's just power supply noise. So watch at the top of the screen. You can see these amplitudes changing. And I'm going to just stop talking because I'm going to race through this. And it'll be more interesting when you watch it go through faster too, I think. All right, guys, so it finished, and we're going to add to new graph. All right, there we go. And let me just stretch this out. Make it long and skinny so the window doesn't change the gains and phases on top of each other. I wish you had more control over how it displayed things, but anyway, there we go. And you know what? It actually looks, boy, it actually looks the same as it did before. Okay. That's a little surprising because the signal that it put out was a lot higher. And, so, okay. Well, there's that. Looks like the same windows we had before. Yeah, doesn't that look the same as before? Now, I'm going to try one more thing. I want to try something because I want to run the okay, I want to run this first one. I feel like this one looked a little bit different for some reason. So let's just run this guy here. It's called frequency response chirp. Not sure what that. It runs really fast, and let's just see what it does. I mean, it's super fast, so maybe that's why they call it chirp, but we'll say add to, okay, I'll say add to existing graph, see if it puts on top of the other one. No, I don't know, oh, maybe it's because I closed or dropped the window down. Alright, so I think it's off the screen. And so Y1 min value. Okay, so I'll put 10 dB. And for max, I'll put 30. Well, maybe I need to go, I'll go 60, just see where, 50. Alright, I'm going to go 100, just to see where the heck it is. Oh, am I changing, Y1 is phase, so... Okay, sorry guys, I messed up. Y1 is right here, max. I'm doing Y2, so let's do Y1, and let's do 60. All right, so the phase is this color here, and series 1L gain is this guy here, which is right at 30. So it's showing that it's 30 dBs. So it's even higher decibels than these other two. Wow, this has me perplexed. Yeah, and right up here, I'm not sure what's going on, guys. Right here, it shows it's like, what is that, 23 dBs. So it's showing that it's a lot flatter, and then it drops off. This part I understand, but okay. Yeah, this little chirp one, I'm not sure. I haven't used that much, so I'm not sure what it's doing. I need to read the manual. Sorry, wasting your time on that one. Just thought it'd be worth looking at. But let's jump to Omicron and see if the gain really is that high. I don't know what else to change because maybe I'll play with it for a minute. If I see something, I'll come back and let you know. But meanwhile, let's jump over to Omicron. Okay, so I've got the screen. So I've got everything set up, ready to go. Trace, over on the far right, the top red is trace 1. That's the magnitude in decibels you see there. And I've got it set for plus and minus 30 dB. Yeah, it's just easy to set that up. And over here on the left, you can see plus 30 here. And it says magnitude here. And trace 1. Down here is minus 30 dB. Okay? Then back to the right, trace 2 is blue. And it's phase, and it's set for plus minus 90 degrees. So on the axis right here on the right, you can see plus 90 at the top, minus 90 here. And it just turns out the way I set it up, 0 is the same right here in the middle of the screen for both. So that kind of makes it easy to watch them. Now, these cursors, I set this one for 10 hertz, this one for 1K. So that's good. It'll tell us the decibels and all that stuff here. So you can change these things. You can add more cursors. You can do all kinds of stuff with cursors. And then over here on the left, frequency set up to sweep. It says sweep right up here, first of all. Now I went to fixed, okay? Now I'll just show you that real quick. So I go to fixed, and I can change the source level, and I can set up so I can find out where my 1 volt or my max is and my 1 watt. So it turns out that -4 dBm is going to give us the 1 watt, and 10 dBm is going to give us the 13.58 volts, which is, about 20, it's pretty close to 25 watts. I think I probably could have got a little closer. It's 13.58, so it's a little bit lower than 25 watts, what I did before, but, fractions to get the right on the 25, but it's close enough to compare to the other things. So let's go back to sweep, and then 10 hertz, 100K, and it's logarithmic. The sweep is logarithmic. 200 points. If we see like funky looking jaggedy edges, then we can increase that resolution. See, there's lots of resolution we can go to. But with these Bode plots, a lot of times you don't need to change that because there's not step changes. So we're going to go to constant level. So we're going to keep the level constant instead of like, I could do a shape level, like have a certain level for part of it, maybe higher here and lower here or something, or vice versa. But I think constant works fine. And the receivers are both 40 dB just to keep them from overloading. And if I come up here in this window here, it shows you that 40, 40. This shows you all the technical stuff kind of in a picture form. The DUTs are amplifier, our signals coming into the amplifier, and channel 1 is looking at that signal. Channel 2 is looking at the signal on the output. So they're right at the input and output of the amplifier. Okay? And I've got ×10 for probe 2 because I got a ×10 scope probe there. Alright, so I think we're all ready to run it. So I can do a single trace, or I can run it. And you know what? I went down to 10. Well, I started off at the max. Yeah, let's go ahead and just run the max one. Okay. Now in this one, I don't have like a program where it's set up. Let's see, is it running? Oh, you know what? Shoot, I turned off the amplifier for a second. I was making some connection changes. Okay. Well, anyway, you can see it runs really fast. So that's one thing about this. It's a little different than the QuantAsylum. This one runs the traces super fast. Okay. So you can see how the gain started at 18, went up to, well, 10 hertz, it says 18.2, 1K it was 18.8. So 1K is right here, and it's already started dropping at 1K. So you know what? Let's see what it is at 100 hertz. Let's change that to 100. Because it's interesting how the gain is kind of, I mean, it's not changing much, right? It's just fractions or, dBs or whatever. But it is 100 hertz, 19.4. So it changed 1 dB from 10 hertz, which we really don't care about 10. I only did that just to point out how it starts up. But if I go to 20 hertz, where where really the audio spectrum starts, then we're at 1907. So we didn't even change a half dB from 20 hertz right here to up here. Okay, but then it did drop down. So from 100 hertz, I'll leave that one there, and I'll change this one to, let's first change it to 10K. And at 10K, it's dropped down 17, so it's dropped down about a little more than 2 dBs right here. So it's already kind of rolling off. And then let's see, let's look at 20K. See what it turned out to be at 20K. And man, it's dropped down to 14. So from 100, the highest point, it really dropped down. So yeah, so the gain doesn't seem to be really constant across there. That's kind of interesting, right? But still, it's not changing that much. Maybe more than what we're used to on some amps, but as far as plus minus, if you said like 19 dB was the medium, then it's probably, plus minus 1, except for where it rolls off here at 20K. And as far as the phase, you can see the phases in the blue. Zero's right here, hitting 0 right about just before 200 hertz, which is right here. And so it starts off about, I don't know, what is that, 25 degrees up, and then drops down, and then at 10K, well, see, it really starts to roll off, but let's say at, what is this, 2, 3, 4, 5, 6K, it's about 20, so that's the plus minus 25 or whatever, and then at 10K it's dropped down to minus 35, and 20K it's minus 70. It's really dropped off. Some people say phase doesn't matter. I'm not too sure about that. Maybe where it's hard to hear this stuff up here, it probably doesn't. But anyway, so there we go. Okay, now what I can do is come up here, and I think I go to measurement, and here's data where I can save things. And so I'll just say new memory. Whoops, I click on that. I'm not sure if it's saving that memory or not. Let's see, do I have to, maybe I have to stop it. Okay, let's try that. Then we'll come over here, and now I'll go up here and say new memory. Oh, there we go. Yeah, I guess I had to stop it so it knew what to save. So over here on the far right, you see it in green. So I can hit the trash can, I can do these things. But yeah, so now we have this waveform that it's been saved, okay? So let's go ahead and do, instead of 10, let's just drop down to minus 4. That 1 watt spot. We'll just do the extremes, okay? So minus 4 dBm, that should be the 1 watt. Let's go ahead and run that. So go back to home, say continue. All right, well, it looks like it's taking off on the identical curve. Okay, it did separate. So with the 1 watt, it did actually come out here to 20K a little bit farther before it rolled off, and the phase kind of shows that as well. All right, so I don't know if there's any reason to do the ones in between. There are going to be something in between this. I guess I could go to about I'll do plus 4, okay? Well, you know what? Before I do that, here, let me stop this, and then go to measurement, and go to memory, and make another new memory. So now we've got those two saved. Okay, so now we'll go to, I should have done something a little bit higher, I guess. Let's see. 0 dBm is like 2 watts. So let's go to 5. Let's just go to 5 dBm and run that. It's not surprising. It's following the same curve as the other two. I think what we're looking for is at the higher frequency, does it go closer to the 1 watt or closer to the 25 watt or 20 plus watts? And it looks like it goes closer to the to the 1 watt. So it looks like you have to go pretty high in amplitude before, maybe if I was just a shade under that. Here, let's go stop this. Okay, now I'm curious. Sorry, didn't mean to make this too long. I was trying to go fast, but then I get curious about things like this. So what I want to do is, instead of going right at 10, I'm going to go at 8 dBm. So we're going to be pretty close to 20 watts, right close to 20 watts, and we'll see if it follows the higher power trace, or yeah, we'll see. It's probably going to be somewhere between the last one and the high power. Yeah, and it did. It fell right in between. So there we go. So it's just slowly approaching so the two high power ones are getting, you know, a little higher out. It's just kind of interesting it's doing that. All right, guys, that was Omicron. What do you think? The setup's really easy. It does Bode plots super fast. It doesn't do the THD thing though, so we're not seeing distortion on this. It's meant for, it's not meant really to do THD, okay? But what it does do is it does it super fast. The screens are really clean and easy. There's, like, all the setup stuff is really easy to find. I find with the, with the other one that I have to go into setup. I have to find, go to pull down menus and look at things. Where here, I can go to that transmission gain screen where it shows me pretty much everything, and I can go set up things right on that screen. Or here, I can see all the different things I need to set up, and I just find the softwares, and then as far as the bandwidth and doing other things like component measurements and stuff like that, that's where it really shines, that 50 megahertz bandwidth, where, yeah, if I didn't mention before, it's 50 megahertz bandwidth, where the QuantAsylum, I think, is 100 kilohertz bandwidth. So, drastically different there. As far as Bode plots, 100 kilohertz is just fine. But as far as, having some wide bandwidth and really fast traces, and a clean, easy to see screen, yeah, I mean, but you're paying a lot for it, right? But, there, some of the things you want to do, we can do input and output impedance, that kind of stuff too, which I'll show you in other videos. And I've done some things where I've looked at cables. We're going to do a lot more of that, especially when we start looking at interconnects, audio cables, audiophile cables. Do they make a difference? We're going to take measurements and we're going to see what we find, okay? Anyway, all right, guys. Well, yeah, you can compare the two measurements between the two instruments and all that kind of stuff. I want to thank Omicron. 2 thumbs up to them for sending me out this instrument. I've had it for a couple years and I haven't used it near enough. So I'm going to start using it more and more, especially when I'm doing some of these comparisons of cables and things like that. And also components, like when we make inductors and transformers and so on. So I'm going to start input and output impedance for filters and things like that. Things are really important. That 50 megahertz is going to come in really handy for that kind of stuff. So 2 thumbs up to my patrons as always, and to my members of my channel. Thank you to them as well. And also, I have a team member. I always want to give an extra thumbs up for that guy. That's really awesome. And you become a member by just clicking that button down below, or you can become a patron by going down the description and seeing the link for for Patreon, and you can become, for I think it's as little as $1 a month. The membership might be a couple bucks a month, I'm not sure. But anyway, the membership thing, it gives you some icons or something like that. It kind of gives me, it shows me and other people that you're a member, and so I can answer your questions and that before I think I do a pretty good job. I can't do them all, but I try, and I sit down whenever I'm not doing anything, or when I'm sitting there watching TV with my wife or whatever, I'm sitting there answering questions, or comments. But all right, guys, thanks a lot. Appreciate it. Hope you like it. Freeway Support channel is just like the video and share it, that kind of thing, and also to use those links. A lot of the links have discount codes, like the Kaiweets one, and a lot of these power stations, the batteries, lithium batteries, a lot of those kind of things, and some of the meters in that. I think, I'm not sure which all meters do that. And yeah, anyway, thanks a lot. I appreciate it, and we'll catch you next time.